Okay, so today we will discuss about the bivariate normal distribution. Till today we have discussed about the univariate normal distribution. Now we'll talk about the bivariate normal distribution. A random variable xy is said to have bivariate normal distribution if its PDF is given by f of xy is equal to 1 upon 2 pi sigma 1 sigma 2 square root of 1 minus rho square e raised to minus half 1 minus rho square x minus mu 1 upon sigma 1 whole square minus 2 times rho x minus mu 1 upon sigma 1 y minus mu 2 upon sigma 2 plus y minus mu 2 upon sigma 2 square. ये लेट आते हैं ना, मेरे को परेशान करते रहते हैं, टू टू करते. So So when you say that xy is said to be a bivariate normal distribution, if it has this PDF, and it is very simple to remember. Okay, there are two random variables x and y. So if they are independent, rho is nothing but it is a correlation between x and y. So rho is 0, so it is nothing but you can say that it is 1 upon 2 pi sigma 1 sigma 2. So we know that individual probability is 1 upon root 2 pi sigma 1. Suppose x has normal mu 1 sigma 1 square and y has normal mu 2 sigma 2 square. Okay, then we know that the joint probability is nothing but 1 upon root 2 pi sigma 1 e raised to minus half x minus mu 1 upon sigma 1 square, and another PDF of y is 1 upon root 2 pi sigma 2 e raised to minus half y minus mu 2 upon sigma 2 square. But here x and y are not independent, they are jointly distributed and they are bivariate normal. So of course x and y have a some correlation, and that rho is nothing but it is a correlation between x and y. Okay, so the PDF is nothing but 1 upon 2 pi sigma 1. Earlier it is a root 2 pi, that is a 2 pi sigma 1 sigma 2 was there, so that is, and this part will be added extra, that is 1 up square root of 1 minus rho square, and e raised to minus 1 upon 2 1 minus rho square, that part is extra added. This part was earlier, but this part will be added, that is minus 2 times rho x minus mu upon sigma 1 y minus mu 2 upon sigma 2. If you take rho equal to 0, then there is a correlation between x and y is 0, so we say that x and y both are independently distributed, so that we can have the x having this and y having this. But in short, this is the PDF. What is the range of x and y? Because x and y are jointly bivariate normal, the range is minus infinity to infinity. The mu1 and mu2 both are also on a real line, minus infinity to infinity, and both sigma 1 and sigma 2 are greater than 0, and the value of rho, it is a square. If you write it is a rho, then it is minus 1 to plus 1. Okay, mu1 is nothing but the mean of x, mu2 is nothing but mean of y, sigma 1 square is a variance of x, sigma 2 square is a variance of y, and rho is nothing but correlation coefficient between x and y. Okay, this is referred as a bivariate normal distribution with 5 parameters: mu1, mu2, sigma 1, sigma 2, and rho. Okay, so how will you write the bivariate normal distribution? If you say that x and y having the joint bivariate distribution, it is represented by x, y is distributed as bivariate normal with mean mu1, mu2, sigma 1 square, sigma 2 square, and rho. And if you say that mu1 equal to 0 and mu2 equal to 0, sigma 1 square, sigma 2 square is 1, then it is distributed as a bivariate normal 0, 0, 1, 1, and rho. So it is going to be a standard bivariate normal distribution. And the bivariate normal distribution has the parameters. This is for the standard bivariate. as the parameters mu1, mu2, sigma 1 square, sigma 2 square, and rho. Sorry. And if you write mu1, mu2, and sigma equal to 0, and sigma 1 square, sigma 2 square equal to 1, then these are nothing but the parameters of a standard bivariate normal distribution. And the probability of standard bivariate normal distribution, if you look for the tables of standard bivariate normal distribution, you have to use the Hartley-Pearson volume 2. That is, the tables are available in the Hartley-Pearson volume 2, that book. So, in short, when you say that x and y are bivariate normal distributed, if its PDF is given by f of xy is equal to f of xy 1 upon 2 pi sigma 1 sigma 2 into square root of 1 minus rho square into e raised to, that means e raised to is exponent, it is minus half of 2 1 minus rho square x minus mu1 upon sigma 1 square minus twice of rho x minus mu1 upon sigma 1 लिखने की प्रैक्टिस करेंगे तभी आएगा y माइनस म्यू 2 अपॉन सिग्मा 2 प्लस what is plus y minus mu 2 upon sigma 2 whole square. So this is nothing but the PDF of a bivariate normal distribution. It is given that the value of x and y is lies between 0 to infinity. Value of mean, that is mu1 and mu2, is lies between infinity, and sigma 1 square is greater than 0, sigma 2 square is greater than 0, and further the rho is nothing but the correlation coefficient between x and y is lies between minus 1 to 1. We can also take equality sign, no problem. So now I wish to find out what is the probability of x greater than 0 and y greater than 0 in a bivariate normal distribution. So let us find out the probability of x greater than 0, y greater than 0. So we know that the x and y both are continuous. Now if it is x greater than 0, y greater than 0, that means x is taking from 0 to infinity, y is taking from 0 to infinity. So in short, basically you can write this as double integration 0 to infinity f dx dy. But what is f of xy? It is given as this. So we are considering the standard bivariate normal. So of course the mu1 equal to 0, or you can, let me show you here. If you write mu1 equal to 0 and mu2 equal to 0, sigma 1 square equal to 1 and sigma 2 square equal to 1, then f of xy, this is constant as it is 1 upon 2 pi, sigma 1 is 1, sigma 2 is 1, and then square root of 1 minus rho square, and then e raised to minus 1 upon 2 1 minus rho square, but x minus mu1 is 0, and sigma 1 is 1, so it is a x square minus 2 rho x y plus y square. So this is nothing but the standard bivariate normal distribution having the parameters 0 0 1 1 rho. So that is what I have written here. Okay, now I wish to have a polar transform because I wish to find out the integration of this, some value of this. Okay, so what I do, I will assume that x is equal to r theta and y is equal to r sin theta. That means I am using the polar transformation. So what is the rho minus 2 rho xy? So minus 2 rho xy is minus 2 rho And what is x? X is r cos theta, and y is r sin theta. So r into r, that is r square sin theta cos theta. But we know that sin 2 theta equal to, it is a 2 sin theta cos theta. So I can use it as a minus rho r square sin 2 sin theta cos theta equal to sin 2 theta. So that means I can get this. Now I wish to find out the Jacobian from xy to r theta. So we know that how to find out the Jacobian. Jacobian of xy to r theta is nothing but del x by del r, del x by del theta, is it? Del y by del r, del y by del theta. What is x? X is given r cos theta and y is r sin theta. So now you can find out the Jacobian. What is that? Derivative of x with respect to r. So cos theta is constant and derivative of r is 1. So it is a cos theta. Derivative of x with respect to theta. So r is constant, and what is the derivative of cos theta? It is a minus sin theta. So we can write it as a minus r sin theta. And derivative of y with respect to r, it is a sin theta, and this is a r cos theta. So just find out, it is a r cos square theta minus minus r sin square theta. So it is nothing but r cos square theta plus sin square theta, and that is nothing but t. This is 1, so it is a r. So Jacobian between the xy to r theta is nothing but, it is a r. So that is what it is written. Xy r theta is nothing but r dr d theta. Okay. Now we will substitute the range. Okay. So now the range is changing. The range of x is from minus infinity to infinity. Now it is, that was the range of r is changing from 0 to pi by 2. Okay, and sorry, the range of theta is 0 to pi by 2, and range of r is 0 to infinity. Here we have considered it is a 0 because we are considering from 0 to infinity. And that is how it is a 0 to pi by 2 and 0 to infinity. So just substitute this 1 upon 2 pi, square root of 1 minus root square as it e raised to minus. What about this? X square is nothing but r square cos square theta, y square is nothing but r square sin square theta. So what we will get? It is r square. R square minus 2 rho xy is nothing but, what you will get? Minus rho square sin 2 theta. So here r square is there, and here it is a minus rho r square sin theta. So r square is common, so it is a 1 minus rho sin 2 theta. So I can write this r square outside. So it is a e raised to minus r square upon 2 1 minus square, and this is a 1 minus rho sin 2 theta, and this is a Jacobian, that is the r dr theta. Now I will write in this structure 1 upon 2 pi root 1 minus rho square is outside, and that integration 0 to infinity e raised to minus r square upon 2 1 minus r square and 1 minus rho sin theta. And here what I do, I will write as a dr square. What is the dr square? Dr square is nothing but r dr, and I have a r dr is with you. So I can write, instead of r dr, I can write the dr square by 2. So now my variable is what? It is a r square by 2. So what is the coefficient associated r square by 2 is 1 minus rho sin 2 theta upon 1 minus rho square. So it is kind of that. If I am saying that a is equal to 1 minus rho sin 2 theta upon 1 minus rho square. So this is nothing but e raised to minus r square by 2 into a. And r square by 2, let us, if I'm saying it is the e raised to minus ax dx, so what is the integration? E raised to minus ax upon a. And e raised to minus ax is nothing but this quantity as it is. And divide what is a? A is nothing but 1 minus rho sine 2 theta upon 1 minus rho. So denominator may it will come to this. So this part will go up. Let me show you here. What is the density we have? Integration 0 to pi by 2, integration 0 to infinity 1 upon 2 pi square root of 1 minus rho square into e raised to minus r square into 1 minus rho sine 2 theta upon 2 1 minus rho square r dr d theta. Okay. So what we do? 0 to pi by 2 outside. It is 1 upon 2 pi square root of 1 minus rho square. I have taken it outside, and then this 0 to infinity e raised to minus r square by 2, and I can write it as a 1 minus rho sine 2 theta upon 1 minus rho square, and here I can write it as a dr square by 2, and this is a d theta. So now if I'm saying this is a x and this is a, okay, so e raised to minus ax, what happened? Integration, it is a 0 to 0 to pi by 2, 1 upon 2 pi square root of 1 minus rho square, and the integration of this is nothing but e raised to minus r square by 2, 1 minus rho sine 2 theta upon 1 minus rho square, divided by a is e raised to minus ax upon a. So what is a? Is a raised to minus sine 2 theta upon 1 minus rho square, and this is nothing but 0 to infinity d theta. One upon 2 pi square root of 1 minus rho square, and this constant is, I can write 1 upon rho square minus 1 minus rho sine 2 theta, okay, into e raised to minus r square 1 minus rho sine 2 theta upon 1 minus rho square. This is 0 to infinity. If you take r equal to infinity, what happen? E raised to minus infinity is 0. And if you take r equal to 0, so it is e raised to 0. But this is a minus side. Okay. So it is nothing but what happened? It is nothing but 1. So you will get, it is a 0 to pi by 2, 1 upon 2 pi square root of 1 minus rho square. Okay, 1 minus rho square will be cancel out this. So you can also write in this way. Square root of 1 minus rho square upon 2 pi 0 to pi by 2, 1 upon 1 minus rho sine 2 theta. Okay. So let us say what is the answer. We are getting this. Okay. Now if we assume tan theta equal to t, further I wish to find out the integration because I need a final result. So tan theta equal to t. So what is the derivative of tan theta with respect to theta? It is a sec square theta d theta, that is the dt. And sec square theta is nothing but 1 plus tan square theta. And what is the t? Tan theta equal to t. So I can write it as a 1 plus t square. So that is written as 1 plus t square d theta dt. So therefore d theta equal to dt upon 1 plus t square. Now, what about the why I have written the sine 2 theta equal to 2t by 1 plus t square? So you can just write 2. T is equal to tan theta and 1 plus tan theta square. So 1 plus tan theta is nothing but 2 into tan theta. This is nothing but sec square theta, and sec square theta is nothing but 1 upon cos square theta. So I can write 1 upon 2 into tan theta into cos square theta. So tan theta is nothing but sine theta upon cos theta, and this is the cos square theta. So one is cancel out. So what happens? It is a 2 sine theta cos theta, and 2 sine theta cos theta is nothing but sine 2 theta. So I can write sine 2 theta equal to 2t upon 1 plus t square. Okay. So now I will substitute here. This part is as constant. Now 0 to pi by 2. अब pi by 2 की जगह पे अभी यहाँ पे 0 tan 0 is, so t is 0 and theta equal to pi by 2. So what happen? Tan pi by 2 is nothing but infinitive. So t tends to infinitive. Now what is d theta? So d theta is nothing but dt upon 1 plus t square, and 1 minus rho sine 2 theta. Sine 2 theta equal to 2t upon 1 plus t square. So I can write 1 minus 2 rho t 1 plus t square. Now I can just simplify in this way. If I am taking this here, 1 plus t square minus 2 rho t, can I write? This is nothing but 1 upon 1 plus t square minus 2 rho t upon 1 plus t square, and this is 1 plus t square, that is cancel out. Now I will just add and subtracted the rho square. So what I can get? 1 minus rho square plus t square minus 2 rho t plus rho square. Now I will write this as a root 1 minus rho square, and this is nothing but t minus rho whole square. So you can see that this is a kind of a form. Integration 1 upon x square plus s square dx. So what I can write, it is a tan inverse x by a. Okay, so we will use this structure. So what I can write, it is a tan inverse x by a. So it is a, if I am writing something else, so this is nothing but 1 upon a tan inverse x by a. Now what is in our setup? So t minus rho is x, and square root of 1 minus rho square is a. So what I can write, it is a square root of 1 minus rho square 2 pi, integration of that, it is a 1 upon a. What is 1 upon a? A is in our set, it is a square root of 1 minus rho square. So that is 1 upon square root of 1 minus rho square tan inverse. What is x? X is t minus rho, and what is the a? It is a square root of 1 minus rho square. So I can write this, and the range is 0 to infinity. Okay. So just substitute the t infinitive, so it is a tan inverse infinitive. So I say that if tan pi by 2 is equal to infinitive, so what happens? Pi by 2 equal to tan inverse infinitive. So tan inverse infinitive, this is if I am substituting the t equal to 0, so it is nothing but tan inverse t 0, that is it is minus rho upon square root of 1 minus rho square. Now tan inverse infinity is pi by 2, and we know that tan of minus theta is equal to minus tan theta. Okay. So tan inverse minus, similarly, that is same result is also exit for the tan inverse. So tan inverse minus rho upon 1 minus root square, rho square square root. So here minus is outside, so minus minus becomes the plus. So it is tan inverse rho upon square root of 1 minus rho square. Okay, and now I will take the 2 by pi inside. So this is pi will cancel out, it is 1 by 4 plus 1 by 1 upon 2 pi tan inverse rho upon 1 minus rho square. Now tan inverse rho upon square root of 1 minus rho square. Suppose if I am saying let it is a theta. Okay, then what happen? Tan theta equal to rho upon square root of 1 minus rho square. Okay, So what I can say, it is a sine theta upon cos theta is equal to rho upon square root of 1 minus rho square. So I just compare. So what is that? Sine theta equal to rho. So which implies theta equal to sine inverse rho. Okay, so what I assume theta equal to this. So now I am getting theta equal to this. So that is how I have written 1 upon 4 plus 1 upon 2 pi, and this quantity is nothing but sine inverse rho. So this is nothing but when x and y jointly bivariate normal distribution, it is a probability that x greater than 0, y greater than 0. And then for a different value of rho, you can easily calculate the sine inverse rho. So you can easily calculate this probability. And that is how what the Hartley book, the tables of the probability of x greater than 0, y greater than 0 is given for a given value of rho. If the correlation is 0, sine inverse rho is 0. So what is the probability of x greater than 0, y greater than 0? It is a 1 by 4. Okay. Any questions up to this? Anyone?
No, sir.
Okay. It's very simple, straightforward. So whenever you give the seminars, the handout is with you. So you can see that I have derived here the in-between steps. So that steps you have to derive and you have to show. Okay. So when you prepare your own notes, so of course you have to derive the steps in between. So at that time of the seminar, you do not require to derive that because you have to simply present because you have a limited time to present. Now we have given that both x and y having the joint bivariate normal distribution. Now I wish to find out what is the distribution of x, what is the distribution of y. That is the marginal distribution of x and y. So I will show that marginal distribution of x and y are nothing but they are also a bivariate normal. Okay. And similarly, we will find out the conditional distribution of x and y. Just hold me, hold on. Okay, sorry for inconvenience. Now we will find out the marginal distribution of x and y. Okay, so if x and y are jointly bivariate normal distribution, then individuals variables follows the univariate normal. That is the property. But the converse may or may not be true. That means if x and y are both are univariate normal distribution, there is no guarantee that both x and y are jointly normal bivariate normal distribution. But if they are bivariate normal, individuals are normal. So that we will prove from here. Further thing is that we will try to find out the conditional distribution of y given x. That means we wish to find out the marginal distribution of x, and we will also find out the conditional distribution of y given x. And we will show that it is also a normal. Marginal is normal and conditional is also normal. I will show you for this you have to find out in the homework f of y and f of x given y equal to y. Okay, nothing, it is very simple. So let us understand the marginal and conditional distribution. Let x and y both have the bivariate normal distribution with parameters mu1, mu2, sigma 1, sigma 2, and rho. You can write sigma 1 square, you can write the sigma 2 square, or you can write sigma 1, sigma 2. Okay, but let us continue with this. Then the PDF. So we know that the bivariate normal distribution PDF, it is a 1 upon 2 pi sigma 1 sigma 2 square root of 1 minus rho square e raised to minus 1 divided by 2 into 1 minus rho square in bracket x minus mu1 upon sigma whole square minus 2 rho x minus mu1 y minus mu2 upon sigma 1 to sigma 2 plus y minus mu2 upon sigma 2 whole square. Okay. Now, if I'm writing this part, that is y minus mu2 upon sigma 2 square minus 2 rho x minus mu1 y minus mu2 upon sigma 1 to sigma 2. So first I will say that. What I do? I will add and subtract this quantity, rho square x minus mu1 upon sigma 1 whole square. So add and subtracted. So now this is nothing but it is a something like that, x minus 2ax plus s square x minus a whole square. Okay, so this is nothing but I can write it as a y minus mu2 upon sigma 2 minus rho into x minus mu1 upon sigma whole square. Okay, so I can write this. But what is the additional term is here? This term is here. So this is nothing but x minus mu1 sigma square. Okay, so what I will do here, I have here subtracted this part. So this quantity I have, this quantity I am writing minus rho square x minus mu1 upon sigma 1 square, and by this I am substituting this. So that is nothing but y minus mu2 upon sigma 2 minus rho x minus mu1 upon sigma 1 whole square. Okay, so this quantity is constant, so I will take it outside. It is a 1 minus rho square this, and this is nothing but if I am taking the 1 by sigma to outside. Okay, so sigma 2 square come outside, that is a y minus mu2, and then so this quantity I will write. If I will take the sigma 2 outside, so I can write it as a sigma 2 square. It is a y minus mu2, and this is nothing but rho minus sigma 2 x minus mu1 upon sigma 1, okay, whole square. So I can write it as 1 upon sigma 2 square. Can I write it as a y minus this side? Okay, so it is a minus mu2, and this is minus common, it is a rho time sigma 2 upon sigma 1 x minus mu1. Can I write? लिख सकते हैं ना यहाँ पे, तो वहां पे गया माइनस कॉमन ले लिया तो mu2 प्लस दिस. Okay, so that is what it is written. So now if you, this is nothing but this quantity, so this is in the power of e raised to minus. Okay, so this is nothing but e raised to minus 2 into 1 minus rho square, and this quantity as it is I am writing here. Okay, so what will you get? It is 1 upon 2 pi sigma 1 sigma 2 root 1 minus rho square e raised to minus 2. This quantity here I am writing x minus mu1 sigma 1 square. Here there is a mistake. What mistake? Here there should be a into this 1 minus rho square. Okay, and then it is a e raised to minus 2 time. Here the sigma 2 square is outside, so this is the sigma 2 square 1 minus rho square, and this is nothing but y minus mu2 plus rho sigma 2 upon sigma 1. Okay, sorry, here there is a 1 minus rho square is additional, so that is cancel out this, so that means okay, this is correct. Okay, so this is you have a two different things. So now you can write this as a, if you write this as a 1 upon root 2 pi sigma 1, okay, into 1 upon root 2 pi sigma 2 into square root of 1 minus rho square. That quantity, if you are writing with this and this quantity with this, so it is nothing but, you can write in this way, 1 upon root 2 pi sigma 1 e raised to minus 1 by 2 sigma 1 square x minus mu 1 square, and this is 1 upon root 2 pi sigma 2 square root of 1 minus rho square, and this quantity. So this is nothing but the univariate normal with mean 1 and variance sigma 1 square. And this is nothing but, it is also a normal, but it is a conditional because x is present here. So it is a distribution of y given x. It is also a normal with mean mu 2 plus rho sigma 2 upon sigma 1 x minus mu 1, and variance is sigma 2 square into 1 minus rho square. Okay, so if you, because this is the PDF of this, so if you integrate over the y, what happen, this become the 1. So that is saying that if you integrate this fxy, we get the marginal distribution of x. We know that if you wish to find out the marginal distribution, how we find out? Suppose if the conditional distribution of x and y is, let us say, denoted by f of x, y, okay, then the marginal distribution of x, how will you obtain? We integrate f of x, y with respect to y. How will you obtain the marginal distribution of x? Just integrate over the x. We get the marginal distribution. And if I wish to find out the conditional distribution of, let us say, f of y given x, how will you obtain? It is a f of xy divided by f of x. Okay. Similarly, if you wish to find out the conditional distribution of x given y equal to y, it is nothing but joint PDF of xy divided by marginal PDF of y. Okay, so this is where you can easily find out the joint and marginal. So here what happened, we have just used this concept. Because of this, what you can write, what you can write, you can use this expression, let us say. So you can write in this way, the joint is nothing but, it is a marginal of x into conditional density of y given x equal to x. Can we write this? I have just write here. So it is a see, this is the, if I'm integrating with respect to y, I can this. So this is giving me the marginal distribution of x. And if I wish to find out the conditional distribution of y given x, how will you find out? The joint divided by the marginal. And what is the marginal? So this is the joint, and marginal is this. So this part will be cancelled out. So this is the remain. And that is how the conditional distribution of y given x is nothing but the PDF of conditional, or PDF of y given x is nothing but 1 upon root 2 pi sigma 2 1 minus square root of 1 minus rho square e raised to minus 1 by 2 sigma 2 square 1 minus rho square y minus mu 2 plus rho sigma 2 by sigma 1 x minus mu. So this is nothing but the conditional mean, and this is the conditional variance. So if I'm saying that what is the expected value of y given x equal to x, I can write it as a mu2 plus rho sigma 2 upon sigma 1 x minus mu1. And if you find variance of y given x equal to x, it is nothing but sigma 2 square 1 minus rho square. Okay, but can you see this form is somewhere we have seen? If I am saying this as this quantity, if I am writing as a mu2 plus, means I am saying it is a what? This I am saying, let us mu2, I am saying that alpha. Or let us say, yes, let us say alpha. And this is nothing but, let us say beta. So it is a x minus mu1. Mu1 is nothing but x bar. Let us say the mu1 is nothing but the mean of x. So let us say x bar. And mu2 is nothing but alpha plus beta this. So this is nothing but kind of a regression equation. Okay. So when you find out the conditional mean, so you can say that the conditional mean of y given x is called the regression of y on x. And the regression line is given by y equal to mu2 plus rho sigma 2 upon sigma 1 x minus mu1. So when we talk about the regression theory, we say that the joint is both x and y are bivariate normal distribution. And when you find out the conditional mean, that means when given a value of x, what is the expected value of y? So it is nothing but expected value of y given value of x, and it is nothing but this. And that is how we fit the regression line. Is that clear? And here sigma 2 square is greater than or equal to sigma 2 1 minus rho square, because rho square is lies between 0 to 1. So this quantity is always less than 1. So sigma 2 square is always greater than or equal to sigma 2 1 minus rho square. So what it means that when you find out the conditional distribution of, or when you find out the conditional variance of y, okay, then variance always reducing. Original variance of y is sigma 2 square. Okay. But when you find out the conditional variance, what happens? The conditional variance is this, and that is nothing but lesser than the original variance. So it is always advisable that conditional variance is lesser. Any questions up to this? Anyone?
No, sir. No,
So
sir.
in a homework, find out the marginal distribution of y and find out the conditional distribution of x given y. What should be? Any guess? इसका मीन क्या होगा? इसका तो मेरे ख्याल से it is a y mu2 sigma 2 square variance, and this is nothing but x given y, that is expected, or x given y equal to y has the distribution. What is that? It is a normal. It is a mu1 plus rho sigma 1 upon sigma 2 y minus mu2, and this is nothing but sigma 1 square 1 minus rho square. So this is nothing but the regression line x on y. When you find out that conditional mean x given y equal to y, it is a regression line x on y. Sometimes we call them as a mu 1.2. This is called the mu 2.1. So we will see when we come to the multivariate normal distribution. Okay. So when you find out this, you will get this kind of result. And you can see that by this, we can say that x and y both are independently. Okay. They are, you can see that this quantity is independent, this quantity. So x and y given x are independently distributed. And that is how we can write in the form of product. Yes, any questions? Anyone? So we skip up to